In this video, we are going to turn to creating a layout. Such a layout can be created quickly with a few clicks of the mouse. We therefore want to focus on good and maintenance-friendly architecture. If we take note of a few basic rules from the start, the maintenance of the layout and the performance of MagicMark will be significantly improved. In the first step, we will turn to coordinate the logic behind. This is necessary because with a comprehensive understanding of it, the layout can quickly become confusing. In the lower right corner of the preview window, you can see the absolute coordinates. These are related to the center of scanning field. The center has the coordinates x0, y0. The prerequisite for inserting an object is the presence of a container. We add this with a click on New Element. Put the focus on the container and you will see the properties window for the container opens. You can see the current coordinates in the Move group box. These are related to the higher level element, the root graphic. In the next step, we add another container to the higher level container. Its coordinates also relate to the coordinate origin on the higher level container. Now we add another object, which in turn has a relative coordinate reference to the higher level container. At each point, you could now enter coordinates in order to position an object as well as the complete container. You can already see the problem. This makes a complex layout very confusing and difficult to maintain. To keep things clear, we want to define a few rules. When creating a layout, a container is inserted first. This is called layout. A typical layout includes text, geometries, codes, symbols, and logos. We should therefore collect these objects in appropriate containers beforehand. For this, we create a container called text. Then we create a container called geometries. After this comes a container called codes. And finally, we add a container called graphics. These are just example definitions. You are free to give applicable description. The following layout is to be output in the format of a credit card. Therefore, I will create a visual element for myself which will serve to create the layout in the correct size and the correct relations. For this, I create a container called blind and insert a rectangle with the corresponding edge length. The edge length is about 80 mm by 50 mm. I just want the rectangle as an orientation, so it shouldn't be taken into account by the laser. To do this, I jump into the higher level container and type the value 0 in the passes text box. Now the geometry is colored red. This means that this element is not taken into account in the laser process. Now we are going to fill the first container with text elements. In our case, these are a few technical parameters. Take a look into the properties window of the text. There you will find a possibility to define the orientation of the text. I recommend orienting the text to the lower left corner. The orientation refers to the coordinate origin of the higher level container. In the next step, I define the font and the font size. The technical units are now to be assigned values. To do this, I copy the text element and paste it directly. Now I move it by a defined value in the x direction and now write the corresponding technical values into it. Many nameplates arrange the technical parameters and the technical values in a table. MagicMark has no special table function, but a table is very easy to create with standard geometries. To do this, we add another container with the name table horizontal and a container with the name table vertical in the geometries container. I now insert a rectangle into this container and orient it again to the lower left corner. Now I enter the appropriate length radius and get a first horizontal line. To multiply this line, I use the array function of the higher level container. I type in how often the object should be reproduced. Then I define the distance between reproduced objects. Now I have the option of moving the table horizontal container by entering the appropriate coordinates. To make it easier, I take the container into focus and move it to the right place with the right mouse button pressed. Now I'm going to make the same procedure with the vertical lines. Now I would like to add the code to identify the component in my layout. I click on the appropriate container and insert the data matrix code. I orient it again to its lower left corner. Then I enter the content to be encoded. If I want to change the size of the code, I change the values in the size text box. The size describes the dimensions of a single code module. Then I position the code where I want it to be. Now I import the appropriate file and discover that it does not have the correct dimensions. There is a size modifier for this case. You can find it in the yellow modifiers column. Here you can enter a relative size change, or you can also define an absolute size. I choose the absolute size. After that, I pick and place it with the right mouse key. I can now move the resized object again. However, the size modifier also changed the scale of the coordinate system. To be independent of that, I will just move the parent container. In addition to the logo, I would now like to position a little text that should be underlined. The procedure here is equivalent to the previous examples. Now we have our layout. The laser would now process this, but the result is not be good. We see that only outlines are drawn, but the areas are not filled. To do this, we now click on the container and add a filling. I leave the distance between the filling lines at 60 micrometers. This filling now has to be applied to the logo and the geometry. Here it is very important that the filling is always placed in the last position of the container, otherwise the modifiers would affect the filling. Likewise, the filling is applied to everything that is above it. Our layout is now complete. That's it so far. I wish you good results.